For the UIST 2009 Student Innovation Contest, we developed a framework for expressive keyboarding using a prototype pressure-sensitive keyboard from Microsoft Research. Keyboards are usually thought of as discrete input devices, transmitting data one keystroke at a time. Pressure sensitivity adds a continuous dimension to keyboard input, allowing for more expressive and gestural interactions. In our demo, we applied our framework to controlling character emotes in an online game, as well as interacting with digital art. To start thinking about new ways to interact with a keyboard through expressive gestures, we turned to Laban movement analysis, used in theater and dance to describe physical movements. A simplified version of this choreographic system, called Fast Food Laban, provides us with a basic vocabulary of gestures by breaking them down into three dichotomies: sudden versus sustained, light versus heavy, and direct versus indirect. On the keyboard, sudden versus sustained maps to how long a given gesture lasts. Light versus heavy corresponds to the pressure used to hit the keys. Direct versus indirect looks at how much of the keyboard is used in making the gesture. These three feature pairs give us a series of 8 unique gestures which the system can recognize. Since our goal was to design interactions that were expressive and emotional, we next started thinking about what these gestures might mean. We turned to Russell's classic circumplex model of affect, which lays out emotions on 2 axes: high arousal versus low arousal, and pleasure versus displeasure. Beatty et al. Provide a third effective dichotomy by separating emotions, which are short-term, from moods, which are sustained. These 3 feature pairs give us a set of 8 emotional states. The 8 gestures can be mapped onto these 8 emotions, giving us a framework for expressive gesturing. This framework allows us to map gestures to responses in a variety of computational environments. As a proof of concept, we mapped the gestures to the character emote system of World of Warcraft. Here, we demonstrate some of the gestures and resulting character actions. This framework has applications wherever computation and emotion intersect, such as social networking, gaming, art, chat clients, and more. It also has potential as a heuristic tool for gauging affect indirectly in user modeling applications.